don't they? It helps us to go and grow and all those the kinds of things. And of course, there's my lovely wife, Betty, Dr. Betty, right there. You can wait a minute. And of course, one of the things we do is we're part of the same community of people you are. We want to see everyone that wants to be involved in space take a trip. Go out there and find out what you can find out about what's that all about. And of course, this is what we do, and we've been doing for some 25 years since we retired from myself from aerospace and she from education. We've been working with children to help promote the next generation of scientists and engineers. And here's just a few of them. So here we are down at the Endeavor when it passed by in Inglewood, waving hello to it and goodbye, and so forth. Is that all I have here? Maybe it is. Thank you. I think that was quickly what I wanted to walk through there with you, and then I can answer some questions for you. Thank you.
Questions or comments?
Thank you. I'm always enthralled. Yes. I'm always enthralled. At breakfast this morning, I said, most people that I've met over these 50 years since Apollo 11 wanted to know one thing. Why wasn't there a crater under the rocket when it landed? so I spent half of my life explaining that rather than how the laser worked. But anyway, I thought I'd mention that. Yes, sir.
Is that reflector still in use today?
Yes, they are still available. I'll mention that they're still available. I think roughly 3, 4, 5 years ago, NASA and most of the lunar studies groups around the world have completed their lunar ranging experiments, to my knowledge. Yes. Yes.
There's a wonderful book called The Power of the Sea, which I read and I recommend it. It's very enjoyable. But one of the things he points out in that is the tidal effects of the moon.
Mm-hmm.
They don't know far in advance distance and position of the moon, and they can't predict tides really far in advance because of this, because of the variation in force of the gravitational field of the Earth, which the moon is in.
Yes.
And knowing this distance is critical, not just for the nice to know how far the moon is, but tidal effects which affect all of us.
All of us, yes.
Such as he's talking about the oceans of it.
Yes. Well, as you can imagine, for us that took on the job in '69 to attempt to be able to make that measurement, again, this was an experiment for us. This was not an ongoing thing. That work was done again at McDonald Observatory over the past 40-some years, where much of that information now has been brought to scientific conclusion about those details. Our objective was, of course, was to get a return and measure it and be able to do it enough consistency that we could guarantee that what we got was accurate. So again, that was about a 6-inch error. We reduced it to about a 6-inch error. So, but thanks for mentioning that. That's so important to us about how important the Moon-Earth systems that work together, and how those laser experiments were able to bring that information to us. Yes. Yes.
So I was at the Goddard Space Flight Center for the last 30 years, and there's been a lot of work done there with Legios, which is a sphere covered with the same kind of retro-reflectors being used to make detailed measurements of the Earth's gravity field, and all sorts of measurements have been made in the intervening years using the same basic approach. And we're still launching satellites with retro-reflectors on them to improve our.
I'm so happy to hear that. That's lovely to hear. Those are actually words of comfort to my ears. That hard job that we did that still pays off. Yeah. Yeah. Okay. Yes.
Yeah. More of a comment than a question. But are you aware it featured on an episode of The Big Bang Theory in popular culture?
Yes.
An
Yes.
episode featuring the
Yes.
laser beam.
Yes.
Could you discuss some of the activities in Africa or South Africa, specifically on space solar power coming up in the near future?
I'll try to address it in this fashion. of course, we work with the children in South Africa, which was our request from Mandela to help out there. But we are familiar with and have association with some of the big corporations in South Africa, like Denel. You may remember Denel was one of the major electronic and technology companies of the past. But we do hear stories and meet with folk at Denel who tell us some of the experimental work they're doing there with power. So yes, we do have that connectivity, and our youth are getting the benefit that since our now corporation as a member of the National Space Society, I think we're going to get a more formal partnership now between corporations like Denel and our National Space Science Chapter in South Africa. But we'll be able to go more into that in the future, I'm sure. Yes. Yes, okay. Well, thank you a lot. It was just my pleasure to come today, and again, to let you know that Glaser and those guys really, what we did together, collectively together, is paying off, and thank you for mentioning some of the latest work. I really appreciate that. I'm going on to other things, but it's always good to know that something you pass along still does a good job. Thanks a lot. Okay. And again, I've got a reflector here if anybody would like to see one.
Don't let it out of your hands.
Oh, yeah.
We can't be trusted.
I think this may be the only one left.
Thank you.
Okay, thank you. Okay, Jeff. I'll pull that out when you get a chance, yeah. I'll give you a copy of it.
Yes, please. And someplace here is. Nope. Nope.
When you get a chance.
Here.
I won't let you. Thank you.
We've spoken a lot about the there. Okay, fine. We've spoken a lot, and now it's dead. That's hilarious. I got it to stop rotating, but it stopped transmitting. Well, nope, that's just, well, there we go. Okay. We've spoken a lot during the past few hours about activities, both current and planned, and this morning we're remembering the past. I invited the next speaker, whom I've known for, a couple of decades, in particular because of his involvement in thinking about the future during his long career at the at CNES, the French Space Agency, and his involvement beginning 30 years ago, more than 30 years ago, almost 40 years ago, in space solar power. So please join me in welcoming a dear colleague, Guy Pignolet. Thank you.
I have a PDF file here.
Okay. Perfect. Thank you. Yeah. Okay. Very good.
So,
Welcome.
thank you. So thank you, John. Effectively, I've known John for a long time. I'd like to say my space career began in a similar situation 40 years ago because I was a seasoned engineer, but space was something far out, far away for me, kind of magic. And I happened to attend the 2020 conference in Huntsville, which was set up 40 years ago by the forerunner of the National Space Society. I mean the L5 Society and the National Space Institute and also the World Future Society. And I wrote a series of articles, and then I got hired by the French Space Agency as a consequence of that. So that 40 years ago, I wrote my first article about the SPS. Reunion Island is as far as you can go on this planet before you have to go to outer space to go any further. It's right on the about 1,000 kilometers from the antipodes of Los Angeles. So this is put on a map, which is easier to read for people in the southern hemisphere, and on design which was made by Buckminster Fuller. And this is a much more accurate representation of the Earth than the usual flat representations that we have. So I shall go quickly through some of decade after decade of the history of SPS and wireless power transportation. I say transportation rather than transmission because even if we are dealing with electrons and electromagnetic waves, we are not in the same business when we deal with gigawatt of power than the picowatts of energy you have for the signal in your telephones. So the 60s, and mostly what I will talk about is at the end of each decade. We had in the 60s Bill Brown, that we've seen the helicopter experiment, and the first design that possibly everyone knows by Peter Glaser for a geostationary power satellite. So this was followed some 10 years later by a $20 million study, mostly led by Boeing, which came up with, after almost 2 years of studies, to a reference design. And some of the conclusions were that the space solar power satellites were feasible, but this would be too much expensive because of the cost of transportation to geostationary orbit. And at that time, there were people at Princeton with Jerry O'Neill who had thought of using space materials for many purposes. They had the Space Studies Institute, and they wrote to the Boeing people, say, why don't you build your power satellite using materials from the asteroids, where transportation in space is easy, whereas from the Earth it's difficult and expensive. And then you may cut your cost maybe by a factor of 100. And the Boeing guy said, yeah, you're right. We just didn't think of it, which tells how much time it takes for a new idea to grow and mature. Some people said it takes a century from the time you physically, some people become aware that something is feasible, and then you have development and experiment, and before it gets in the industry and before it gets something that everyone is using, it takes about a century, because there are things that move at the speed of light. But we may have billions of cells in our brain, but the signal go only at a speed of 10 meters per second from one cell to the other, and it takes several years for our mind to change focus. That basically is the reason. So there was not much after that in the 80s until some conferences, and a major conference was held in Paris and organized by Lucien Deschamps, who was the chairman of the Power Committee of the International, or I say, World Astronautical Federation, where many the key people were at that conference. And well, by the way, at that time, that's how I got seriously involved, because we made a world contest of cartoons, which was great, and we sent the rules for the contest in English, in French, and in blank to some 3,000 people we had on our mailing list. There was no email at the time or things like this. And we told the people we wrote around the world, the blank form, put it in your own language. So the announcement, on the face it was the announcement for a contest. On the other side, some basic facts about what WPT and the SPS was about. So just basic information. We had it translated in some 10 or 15 languages, and it was distributed from the returns we had to 150,000 people around the world, the leaflets that we had. And we had very good returns on that. The price was fame. You become famous because you do that. Because if we had, say, okay, you could go to some lounge somewhere, no problems. You know, if it comes from the southern part of some exotic country, I don't know where. But if we had winners from the northern part with different political organization or whatever, it may have become very complex, so we tried to avoid that. And the winners eventually got a job with the European Space Agency as a result of their good drawings with the publication of the European Space Agency. So that was great. Then comes in, that's where we start hearing from John Mankins and new look designs for NASA, and very innovative, that changed the view from what we had from the reference thing. And also from Japan, there was a famous professor, Professor Nagatomo, who made the SPS 2000 design that from that I went to work in that lab for several months, and we made a model for demonstration which we can carry in a suitcase. 6 models were made that have been all around the world and still working, some of them after 20 years of operation, to demonstrate to people what it is about. I must say that's the first time I went to a model, which was a model made by Peter Glaser, and when I went through the beam, I was scared, just for dead fried chicken effect, and we didn't, and we're still there, so that's one point. So again, there was not much for maybe another decade until there was this thing at Fukushima, which shed a new light on nuclear power and led people and decision makers on a world level to think again about other sources and solar power satellite. And then we had, up to that time, a group of researchers in the United States, group of researchers in Japan, maybe 100 people each side, some people in Russia, but they stopped most of the activities after the shift from Soviet Union to Russia, and maybe a dozen of researchers in Europe, half of them in Reunion Island, where we still have the leading laboratory in Europe for wireless power transportation. So Fukushima was a big accident, but also crisis is danger, but also opportunity. When you write in Japanese or Chinese, when it says crisis, it's 2 signs, danger and opportunity. So it was an opportunity for SPS revival, and studies have been thriving again with a new entrant, and we spoke about Professor Liming of CAST, who's been very active, and we have also Professor Shi Weidong, who is here, and who are very active now in China for that. And we have stepping stones and things that come on the side, which was mentioned yesterday. because wireless power transportation is not only for bringing back the energy from future SPS to the surface of the Earth, but there are many other applications, including short distance for recharging, the batteries of cars or small devices, and it has become a big industry. And after I leave this conference in 2 weeks from now, I will be in Montreal, where there will be the first World Wireless Power Transportation Conference, mostly by an industry that most of them don't know much about space activities, but we are going to make the link, and because it's getting such a powerful industry, it may be a great stepping stone for our own purposes. So I will finish this small presentation. For people who are at the Space Power Committee at the World Astronautical Federation, thought it would be good to have a World Research Center for WPT. And last year it was decided that the base would be in Reunion Island. So we worked on that. And what will be the purpose? The purpose is to explain SPS and wireless power transportation to politicians and industry decision makers. Most of them, except for the people who are here, are not aware of the potential of space activities. I came from Reunion, because it's on the opposite, via China, because we have a direct airline that goes twice a week to China and from China to Los Angeles. And I was speaking with one of the attendants in the aircraft and about what we were doing. And she asked me, when people went to the moon, is that real? I thought that it was a TV series, like many. And so that's what we have to deal with. So I won't have to explain WPT or SPS to anyone who is around here. And we do our research and manage to communicate to each other. But we have to put this in words, simple words, small things that we can forward to the news and that the politician can read in their own language to know that it is real and important. So this is the purpose of the WPT World Research Center. So we'll work basically like 2 information notes every year. Probably one will go out after this meeting. And this is the logo. So you have the sun in the back. You have a sign, which is a wave, and we have a line. It means that we will transport, and at the end, it's like the head of a bird for a discrete sign that this is a tropical bird, that it's coming from Reunion Island. And that's where we are. You are welcome also 2 things. To contribute in political and top industrial blah, 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 to put words about what we are doing, but also to send me addresses and institution and organization that will relay, to which we can feed and forward that information that will go after to the decision makers. Thank you.
Any questions?
How is the power generated on Reunion Island? Is it coal power plants or what?
A few years ago, we had half of our production from biomass, from burning sugarcane. But because of demand in energy, we are using all our sugarcane byproducts to make energy. But now it's only 20%, because the demand has grown, and capacity for making biomass energy is limited. So the rest is fuel and coal and a little bit of hydroelectricity, because we have a lot of water falling from the sky.
Would you be willing to consider Reunion Island as a early location for receiving solar energy from space?
Definitely.
Okay.
So we have, by the way, we have made a study for sending energy 10 kilowatt continuous to a village at the bottom of a canyon, deep canyon, where for many reasons like aesthetic and things like this, we don't want to put wires, which would be easy to do. But it's such a beautiful landscape that we don't want to do that. We prefer to do it by WPT. And here, from the conversation yesterday, there was another idea. This is very similar. We could do that on the moon from the peak of the eternal light on the Shackleton crater to beam energy to instrument at the bottom of the crater on the moon. That would be very similar to the project that we have in Reunion Island for our for one village.
And what's the beaming distance you require for that?
The distance is several hundred meters only, 700 meters. Yes?
So what is the current status of the space solar power development in France or in Europe?
It's getting, we had in Reunion Island the largest solar panel farm in France. It's growing, but slowly. It takes a lot of time for our institution and national energy board to understand that we can have private production of electricity. That's, administrative difficulties, but it's growing. Okay, you had a question there? Okay.
I'll speak to you later if I have an idea.
Yeah. We also have some studies for using the thermal energy from the ocean, because we can go. In fact, Reunion Island is a volcano, one of the largest one on the planet. It is 7 kilometers high from the bottom of the ocean, and it just goes like this. So the depth of the ocean is 4,000 meters, so we are 3,000 above sea level, but it just goes like this with a base that is 200 kilometers wide. But it goes very quickly to depth where we have 4 degrees Celsius, 4 degrees centigrade, which can be a cold source, and the surface is about 25 degrees all the year, the surface of the ocean. Maybe we could do something. Thank you. Okay. So I don't know how to get this out.
Just pull it. But I want a copy.
Okay. Thank you.
Do you have one on here, John?
No, I'm bringing it up.
Okay. All right. Okay, our next speaker will be John Mankins with Mankins Space Technologies, and he'll be offering his perspectives and experiences with respect to the space solar power initiatives. You ready to go, John?
You bet.
So I started out as a perfectly happy frequency and timing engineer at the Jet Propulsion Laboratory in the Deep Space Network, measuring the synchronization and synchronization and timekeeping of cesium and rubidium and hydrogen masers supporting deep space tracking, and ended up in 1995 managing a new program for advanced concept studies. This is before NIAC at NASA, the NASA Institute for Advanced Concepts, for a gentleman by the name of Ivan Boike, who doesn't come to these events very much, but is very much a great visionary. And Ivan asked me to take a look at the subject of space solar power, which I'd never had any involvement with whatsoever, to see whether or not the technologies that had emerged during the 15 years since the cancellation of U.S. activities in 1980 or 1981 might have enabled new architectural concepts for space solar power that would change the economic results. And I was very interested. I said, sure. And I immediately got approached by the space solar power mafia.
Well said.
You have to understand that after the end of the space solar power program in the United States in 1981, that those people who were involved with it, who didn't have, actual gainful employment like Dick Dickinson did, were at risk of their careers, because when it crashed very hard, and not for any good reason, in my opinion. We can talk about that at great length, but in part because there's a discussion this morning about the concept, and this was in the opening plenary, of Thomas Kuhn's book about the nature of scientific revolutions and the invention of the idea of a paradigm as a way of framing intellectual research and pursuits, but also of constraining an understanding within a community of what is actually possible. And the idea of the paradigm shift, how you go from one paradigm to another. And just as there is no person more zealous in their advocacy of an idea than a recent convert, so there is nothing more punishing than to have been part of an attempt to change a paradigm and have that change fail. Because all of the people who were involved in pushing back against the paradigm change are comforted in being certain that their view was right all along, and that anyone who pursued the new paradigm was not just mistaken, but evil. And this was in no case more true than in the case of solar power satellites and space solar power in the U.S., within NASA, within the Department of Energy, than during the 1980s after the end of the space solar power programs in 1980, 1981. So coming into this in 1995, and I'm approached by, as I say, the SPS mafia, it was very interesting to me. I didn't realize how dangerous it was to be talking about this idea. And I was invited to go to this conference in Kobe, Japan, WPT 95, organized by this guy I'd never met before, Professor Nobuyuki Kaya, with Gregg Maryniak and many others. And then for the next several years, while I was conducting what was then became known as the Fresh Look Study, I had the enormous pleasure of meeting and interacting with a group of individuals who were the most unlikely group of revolutionaries that you could ever hope to meet. Peter Glaser, Bill Brown, Nobu Kaya, Dick Dickinson, all gentlemen, all gracious, all thoughtful, and yet they were all convinced that this thing, this idea of the solar power satellite and wireless power transmission that I'd never heard of, were not just interesting, but important, worthwhile, and imminently doable. I thought I would share with you very briefly. First a little recollection. So you know Peter Glaser. So he invented the solar power satellite, scientist and vice president at Arthur D. Little Corporation. I don't know if you knew he was born in what was formerly the nation of Czechoslovakia, a little town outside of Prague, that he fled the Czech Republic with the coming of the Nazis, that he went to the UK to continue his education, and that then stopped his education, and during the war, World War II, was a tank commander going back into Europe to fight against the Nazis. And then only after that he returned, finished his education, moved to the United States, became a U.S. citizen, and did all of the other things that he did later in his life. So I'm going to play for you an interview, some comments that Peter Glaser made. I apologize for the quality of the video. So this is Peter Glaser interviewed 20 years ago at the end of the Fresh Look study, which I mentioned a moment ago, when the program manager at that time at the NASA Glenn Research Center arranged to have a video, a CD done, a DVD done, with a series of video snippets on the progress of the Fresh Look study and the various activities. So when you watch this, think not of this elder gentleman and the statesman and innovator, scientist, project manager, but think of the young Peter Glaser as a tank commander fighting the Nazis. at such a life. So, to remember Peter Glaser.
Thank you for the opportunity to discuss the subject that has been very close to my heart for 50 years. And that is this century,
That's about as good as I can get it. Sorry. Let's pause for just a second and see if we can do a little better on the sound. Oh, that's an excellent idea.
So the sound's coming out here. Do you want to bring the mic?
1, 2, 3.
Put it on the,
That's what I'm bringing down.
Oh, excellent. Which is stupid. Okay, ready? Good. Yeah, I'll do it.
space and solar power.
Thank you.
This century, all the requirements of energy on this planet. The way it got started is the realization that we are running out of the available nuclear fossil fuels. We now know that reliance on fossil fuels is going to create unacceptable global warming. We also know that we have the capacity of this century to meet most of the energy needs on this planet. Since 1963, I have participated in the U.S. space program, and thus to be able to come up with this concept of solar power satellites, as it was first called, was rather easy for me, because I believe that we have the capacity in the space program to do all the developments that are necessary to demonstrate that we can convert solar energy in space for use on Earth, and do so within the next 10 years, and then go on to do this on a global scale. The support of the U.S. Congress and NASA was, of course, essential to achieve this. And I'm delighted today that many different countries believe that this is the way to go. It is no longer whether we can build solar power satellite, but how best to build it. And I hope that I will be able to be still of some assistance as this project goes forth, and that we will solve not just the technical, but also the economic and societal and, if you like, political problems that this will entail. So, good luck. And let's hope we can achieve it in this century.
So next, I wanted to, so no change. So now the other side, and I apologize, I'm running over just a little bit, but I don't want to neglect this.
And I'll talk briefly about applications to the...
In 1987, so 31 years ago, Bill Brown went to Northeastern University and gave a series of lectures, a little more than an hour each one, with the intention of conveying to the students, the people who were there in the lecture, and to put on the record through a series of videotapes his experience and his knowledge about wireless power transmission and its prospective applications. So this is just one small excerpt from those 4 videotapes.
Solar power as a solar power satellite application, a video to geotransportation system in the orbiting industrial park. And there's also long endurance high altitude platforms in the Earth's atmosphere that I will not discuss. I first became familiar with solar power satellite when Peter Glaser wrote his first article on the solar power satellite.
And this is really interesting to me. I did not know that until I was making this little video, which I apologize again for the quality, which is poor, that in fact Peter Glaser and Bill Brown had not met previously, and that Peter Glaser was, Bill Brown was unaware of the solar power satellite until Peter Glaser wrote his article for Science in 1968.
Science magazine, which was back in 1968, and then from the microwave power transmission point of view, he and I collaborated quite closely for several years, and we still collaborate closely. And I would just like to read from this report, Pioneering the Space Frontier, that was put out by the National Commission on Space. That was the President's National Commission on Space. It's a very interesting document in which they talked about the future of space. And here they talk about space enterprise. The ideal space enterprise would have a stable, predictable, very large market on Earth, a potential